Hi, Doug. How's it going?
It's going well.
You ready to start some Python lessons?
Yeah, I think the idea here is to start with an assumption of a little bit of Python, but start with making a little tic-tac-toe game and then building that into many tic-tac-toe games, of which would be in the Artemis Cosmos game engine.
Okay.
Um, so you have Python installed, is that right?
Yeah, I installed all the stuff on this computer that you said to install. I haven't used any of it yet, but I'm looking at like Py add-ons, Py runtime, some libpng thing, Oop. And I'm getting a spam call. All right. So is there something you want me to run? Oh, and I installed Visual Studio Code.
Right. I think let's start in Visual Studio Code, assuming we got Python installed.
All right. I'm launching Visual Studio Code here. Got a couple of missions here. Dawn Patrol 2.0.zip.
Okay, so you're in some sort of folder.
Yeah, I'm not sure why that's showing up, but okay.
Well, maybe last time you ran it, we did this. You can do File, Open Folder,
All right, so File, Open Folder.
and then
And I am now looking at Artemis 2.99 mission folder where I've got XML missions.
all right. Well, can you maybe navigate somewhere to create a new folder?
Sure. Um, New folder. New folder on the desktop I'll call Python missions or something like that, or Python programs.
Sure.
All right.
Or Learn Python or whatever, and then add a folder in there called Tic-Tac-Toe or TTT or something like that,
All right.
and then select that folder.
If I could only spell tic-tac-toe correctly. There
Hmm.
we go. Now we're off to a rousing start. I have spelled tic-tac-toe and I entered that folder.
Yeah.
All right. I'm in that empty folder. I'm
So
saying select folder. Okay.
okay. So over here you see Tic-Tac-Toe. You have open editors. Do you see that?
Second, I have to say I trust myself here.
Uh,
All right. Now, I see get started. Yes, I see get started.
mhm.
And
You see the open editors and tic-tac-toe.
yes, it looks similar to what yours looks like.
Okay. So the tic-tac-toe, that's the folder, and we can add a new file. If you see this little icon that shows new file.
Okay, a little new file. Got it.
But, create that and call it main.py.
Main dot
Py, py. When I say py like that.
py. You got it.
And then, we'll just get situated and we'll do print parentheses open
Oh,
quote
okay.
hello world.
So, so after I type main.py, I click, and now I am on the other side under get started. I'm sorry, but I'm not used to this editor. We are also getting used to,
Yeah, that's fine.
yeah. So I want to say print parentheses, quotes, hello world.
It's your basic first Python
Mhm.
program.
Okay. And then enter. Okay.
And in order to run that, we can hit this little on the upper right
Got it.
side. There's a little run button. You hit
Run
run,
Python file. Okay, I will click that.
and the little terminal should come up at the bottom and say hello world.
Mm-hmm.
Good so far?
I got a lot more words than you did, but
Yeah.
yes.
It says hello world.
It also is asking me if I want to try Windows cross-platform PowerShell.
Oh,
And
yeah, blah blah blah. Okay, no.
yeah, other messages from Microsoft. But yes, I also got the hello world.
All right, so we're good and we're getting started. So let's see. The next thing is did you watch the videos where it showed you the basics of Python?
I did. I watched the first video that was the complete overview. I started watching the second video, but it was I was watching not sitting at my computer. I was getting steps, so I didn't actually type any of the exercises. I just looked and but for purposes of this recording, let's do things.
Okay, so
Don't assume I know very much.
well, I also don't want to like go through and reteach the basics of Python, but with Python you can make a function by putting the word def for define, and then
Okay. So how did you move that down? Or did you just drag it or did you hit enter a few times? I'm hitting enter.
I hit enter a couple of times.
Okay,
This is like a text file we're in. Main.py is a text file, and
got
it's
it.
just like Notepad, but with this
Hmm.
you can have multiple files and navigate between the files,
Okay,
and so it's just a text editor.
gotcha.
Um,
Like my XML pad was a text editor for XML. All right,
yeah,
I am writing DEF and it's expecting a function name and you're saying say hi.
yeah. And then you Python is an indentation-based language. Some languages, you have a begin and an end, or curly brace,
Hmm.
end curly brace. Python, you just indent. So
Okay,
by saying define, say hi, open
and the
parentheses, close parentheses, that's the function. And then you say colon to denote the beginning of the function. And then you
gotcha.
indent and you say hello world.
And I indent with the tab key.
Yeah,
All right, I didn't get the four dots like you got, but I have indented the tab key.
that's just a view setting that I had to show white space.
Okay.
Um,
Yeah, my view is not the same color as yours, but
yeah,
mostly
have
it's
a different theme. So
mhm.
if we ran this, it would actually do nothing because all we did is define a function.
Right. We didn't actually execute the function, or we didn't call the function yet.
Right. So
How do I tell it
you
when the function ends?
well, you just outdent instead of indenting, you outdent.
Got it.
And then you could say hi. So this is outdented, so that's back on the main line. And if you run that, it should call say hi, which in turn prints hello world.
So I'm passing no parameters, so I've got empty parentheses there.
Yep.
And I'm clicking my run button. And yes, I got my hello world. And I didn't get Microsoft trying to sell me stuff this time.
All right. And then real quick, we can like start to add like a message. This is like called a parameter
Mm-hmm.
or a function. And instead of saying hello world here, we can say print message.
All right. And so,
And then in
and
say
message.
hi,
All
let's
right.
say yo. Da, da, da.
So message is a variable that's being, it's a local variable within the function that's being received from the function calling line.
Yeah.
Right. And so I'm saying, I'm going to say yo ho ho. All right. And I'm going to run this and it printed yo ho ho. Okay.
All right. So we got functions, we got arguments, and
Mm-hmm.
we're passing them.
Gotcha.
So real quick, you mentioned variables. Variables, you don't have to say anything like var or string or anything like that. You just say my thing equals, and we'll make this something like, hey there. So we're putting hey there inside a variable called my thing instead
Okay.
of
So,
calling. I'm gonna say hi, we'll say my thing instead. And
so,
variables are a way of storing information, and then you can use that name to represent that information.
all right. So now I am going to execute my program and it says, hey there.
All right. Hmm.
Got it. So my thing is a variable outside the function. Message is a variable inside the function.
Yep. So there are things like arrays that you can make multiple messages, let's say. Greetings.
Okay,
Greetings. And an array, actually, they're called lists in Python,
okay.
are with brackets. So you can put multiple values in that. And let's not call hi there right yet. We're going to comment that out, or say hi, I mean. And comments, you have a little hashtag and it comments it out.
Trying to find a way if I can display you as full screen.
Should I share my screen with you instead of as my
So what you're doing right now is you're sending the video of the screen.
yeah.
It actually might be better if you shared your screen. Yeah. Oh. Uh,
Is that better?
no. Uh, layout. No, that's not better.
Should I stop sharing?
um, no, that's not what I want either. Why can't I just see the thing you're sharing as full screen? It's like it behaves differently when it's just one-on-one. What happened? Okay, there, got it now.
Okay, so this is good?
Yes.
Okay, then I'll continue this way. All right, so you've done programming where there's like a for loop.
Yes.
Well, in Python, a lot of things that can be enumerated, they call them iterables, and a list is a type of iterable. So rather than if you in the past had to like do a for loop and index into an array or something like that, you don't necessarily have to do that with Python. You just say for and give it a variable name like I'll do MSG for message, and then you say in, and then you can say it in the iterable thing, which my thing is now a list of things.
MSG in my thing. For MSG. Oh, colon.
Yeah, whenever you start, you
Uh-huh.
start, you start a block with a colon, and then you indent, and then you end by outdenting. So
Okay, and with the indenting, is the next on the for next loop implied?
the indenting tells it that that's part of the for loop. It's
Mm-hmm. And as soon as the indenting ends, it
yeah, yeah,
loops until looping is done.
yep. Mm-hmm.
So I don't have to know the count.
Nope.
So it knows there
You
are
can,
2 messages in my thing and it'll just do it twice.
yep. If,
Well, let me try executing it and see what happens. Wow, how about that?
and that's a like a nice. It's a common way of dealing with things that you can enumerate.
Programming has
For
come a long way since Fortran in the 80s.
yeah. So like if you wanted to, if you actually wanted numbers, you say for I in, and there's something called a range,
Mm-hmm.
and you can um, say for 1 comma 10, and you can, oops, I forgot my colon, and you can print
I in range 1 comma 10. Oops. I too forgot my colon. Print I. Oh, well, how about that?
Now you noticed it didn't print the 10. I don't know if you noticed that.
Yeah, I did notice that. Only I had a typo, so for me it went to 19 and it didn't print the 19.
Okay.
So border conditions are it stops.
Yeah.
It includes the 1 but not the 10.
Yeah. And if you took away the 1, you could say this would be from 0 to 9, I believe.
Mm,
Yeah.
interesting. Okay.
So it's the same syntax for enumerating things and for iterating a range of things. And
Mhm.
there's a lot of collections that you can just enumerate in this same way, which is kind of nice, simple syntax for doing that. Make sense?
Yes, makes sense.
All right, now I'm gonna jump sort of ahead and start talking about classes.
Okay.
You've done programming languages that have classes, have you?
Yes. You got me started with Alice.
Yeah.
It's
So
been years since I wrote my submarine program in Alice, but I've had classes.
so a file like main.py here, they call that a module, and then you can have functions within that module.
Uh-huh.
Another way of grouping things is in a class,
Okay.
and you can just say class and give it a name. My first class. And then again with the colon.
Okay.
Okay. And then you can define functions. Um, we'll say status. How about that? Status. And when you define a function in a class, it has a first argument, and it's typically and almost always called self. I don't think it necessarily has to be called self, but that represents the instance of the class. So a class is like defining a cookie cutter, and then you can make cookies out of it later. And for the individual cookies, they need to understand and have self-awareness, basically.
Okay.
Okay, so self is that argument so that it can refer to itself and get information about that. And for that, we're going to say print. For now, we're just going to say print I'm good in quotes.
Okay.
Okay. Now outdent all the way back out.
Then all the way back out.
Okay, and it's like let's call it my cookie. My cookie. My cookie equals, and then you use the class name to, to create the cookie.
All right. My cookie equals my first class.
And then you can,
And that is,
that's what they call an instance of the my first class class.
okay.
And then just like, well, we didn't do any of that before. No, we haven't even used the dot syntax yet. Um, but to access the status of my cookie, you say my cookie dot status. So it's calling a function on the object.
So the class looks a whole lot like the function.
It does, but it's a way of grouping data and functions. And I did a function first, but next I'll show you some data, and we'll change status so that it has data and it refers to data, and we can show that if we make different versions of this class, they have different data. But for now, we'll just have this function, and if you run it, it should say I'm good at the very beginning.
Okay, so my cookie dot status
Yep.
and then parentheses And that should execute.
Yep.
Oh yeah, there it is. It said I'm good.
Yeah.
It was that last line. Okay.
I don't know. I'm just going to make stuff up. But a way of defining, well, whenever you, I'm going to do this instead. I'll say, whenever you make one of these cookies, like down here when we said my class, it's called initializing it,
Mm-hmm.
and there's a special function called init, and it's I think they call it dunders. It has two double underscores in
Hmm.
front of the name and after the name. You also take the self.
All right, let me go back up to where you are. So at the beginning of defining my first class is def space dunders.
Mm-hmm.
And oh, it's giving me some choices. And you're
Yeah.
used init. Yeah, init is one of them. I'm
Yeah.
selecting init.
Yeah, it should give you a boilerplate code. If it
It
did, I'll
did, yeah.
make sure I have that too. So
Yeah.
that's the same as what you have.
That's exactly what I have.
Okay.
Help me understand what it means.
Okay. So this is the initialization function. It's passing that self in.
Hmm.
This arrow and this none is um, it's kind of documentation that says that this returns nothing.
Okay.
That arrow is says what it returns, and then the none is kind of the Python way of saying nothing.
Okay.
And that's completely syntax sugar, so you can get rid of it or you can keep it, doesn't matter.
Oh.
The word path is a way of saying there's no code here. Just pass on through.
Hmm.
Because if you didn't have it, of course it would bark that you don't have anything in the function body.
Okay.
But by putting that, because it dumped out this boilerplate, you can just say pass, which means I'm consciously not putting anything in here. But
Okay.
we're gonna put something in here,
Oh, okay.
and we're going to say I think, let's see,
I'll delete the pass and put in,
yeah, delete the pass and say self dot money equals 50, and then self dot debt equals 65.
okay. That sounds like a bad situation.
Yeah. So we're gonna update our status to um,
Instead of printing I'm good.
it's gonna print. First, we're just gonna say um, print self dot money minus self dot debt.
Okay.
And if you run that, it
Okay.
prints minus 15.
It did.
So a nice thing to do is to have this um, be able to configure the money and the debt. So in our initialize, we'll put in after the self comma, we'll put in money and debt.
All right. So that is under def init self
So we can now pass initialization variables to this init function, which
Okay.
I'll show you how to do that.
Money, comma debt.
And then we're going to set the self.money equal to money, and the self.debt to debt.
I'm getting undefined errors.
Or
Okay, got it. I see it. There we go.
okay.
I didn't have a self in the init.
Yeah, that's important. Okay, so now this is going to be kind of weird because we're not going to pass the self. It gets magically passed. So when we create the new first class, we have to put in our 50 and 65 down here.
Got it.
Okay. And that should be back to where we were, minus 15.
Mm-hmm.
But now we can create another one of these and call it Fred. Fred's not going to have 500 and only 165, so he won't be in debt. But we got to print Fred.status.
So Fred equal Fred.status. Except I spelled it wrong. And this should execute, huh? Let's see. No, it didn't. My first class.
Did you add the arguments?
Yeah.
Okay.
My cookie equals my first class 5165. Cookie step. Oh, here we go. There it went. Got it.
Okay, so we use the same cookie cutter to make unique cookies, if you will.
Mm-hmm.
My cookie and Fred. But our status message isn't that great. It just prints out numbers, not very meaningful. So this will be give us an opportunity to do two things. First, you can do things like mix strings and numbers, but you have to be kind of careful about it. It's like you have, and then you can say plus, but I think if you run this, it's going to say can't add can't add a number to a string. right? So there's a way of converting a number to a string by using this str.
Mm.
And then, well, you got to put it all the way around this because we want the number there. And that should work. Pretty up to formatting.
Mm-hmm.
I'm going to comment that out and show you a way that I prefer, and I'd like to teach you early so that you can use it. There's something called a format or a template string. If you put an F in front of the string, you can now put kind of these little template things in there. Like using curly braces, you can put an expression in there and put in like self dot money minus self.
You have curly bracket. Curly bracket. Oh, close quote. All right. I got that. I'm with you now.
Okay, so it runs and that prints out.
Oh yeah. Look at that.
So that's a nice thing, and you could use that for creating variables too. The format strings are pretty powerful, and I use them quite a bit.
So the F is print a format.
Mhm. It says this string is a format string,
Okay.
and then you can use it. Does it's not explicit to print. It can be used anywhere. Um, like I use them when I'm making ships and putting the ship name with their side text or something like that. That type of thing.
Okay.
It's just a nice way of doing it without doing quote plus string blah blah all this other stuff. So
Mhm.
anyway, one other thing we didn't talk about, which is conditionals. So let's add one here.
All
You've
right.
probably done if statements and other things.
Yep.
If money is less than self debt. And this is another thing that does blocking. So it ends with a colon and then you indent. Let's say print you are in debt.
And that. Okay. Yeah.
So it should say you have minus 15, you're in debt. You have 335.
Yep.
Um, but you've probably heard of else and other things like that.
That's exactly what I was going to ask. Is there an else for this?
There is, but I was going to show you the curious thing that they decided to do. Normally Python is nice and verbose and help, but they decided to take a little shortcut with else if and call it elif.
Huh.
So let's say if our money is less than uh, I don't know, 50, we'll print you're doing okay. And then we'll say else colon print you're rich. Exclamation point.
Okay. Get there. All right, and else followed by a colon. Else you're rich. Okay, got it.
So Fred should be rich, I think. I remember. Yep, Fred's rich.
Aha. And nobody's doing okay.
Well, we can make one that's doing okay, but we should just to test it. Barney's probably just doing okay, right?
All right, let's go to Barney.
Barney equals my first class. He's only got 45, but he's frugal and he only has $12 in debt. And we'll print Barney's status. He should, yep, you're doing okay.
All right, so status. Oh, okay. Status is the function we defined within the class.
Yep.
Okay, got it. Yeah, all right.
So there's probably a lot more to Python, but this is the basics things. We got the ability to loop over things. We got functions. We got classes. We got initialization of classes.
Mm-hmm.
Being self-aware of its data, and how to call things like that. Are you good? Can we maybe?
I'm good. We're 7 to 12 minutes from me needing to take a break,
Okay.
just to let you know.
Yeah, that's good. But I will talk about what we're going to do next then.
Okay.
And then we could maybe stop recordings and then
Mm-hmm.
go from there. Next, I was going to Tic-Tac-Toe is a very simple
Mm-hmm.
game. And I was going to write basically a, a I call it the board, which is all the state for the game,
Mm-hmm.
and then separate how to display and update the game separate from that board.
Okay.
And then we're going to do that by using just the command line and the terminal to play the game.
Mm-hmm.
And then we'll take the game into other places over time
Okay.
with new learnings along the way.
I like it. All right. So are you saying this would be a good time to
Yeah, let's
pause?
stop the recordings and
All right, let me see if I can do that. And the recording has resumed. Okay, so what's next, teacher?
so next we're going to create a new file called board, board.py, and start to build a tic-tac-toe board.
All right, so I go under, so I had main.py, so I go to plus and I say board dot py. Got it.
That should have opened up.
And board.py is now open. Yes.
All right. So we're going to create a class called board. Just put pass for now. So
Yes. Okay.
in Tic-Tac-Toe, it has like 9 slots, or you can think of it as a 3x3 multi-dimensional array. Blah, blah,
Yes.
blah. I'm going to go and just keep it as a just 9 slots of things.
Okay.
So the first thing we're going to do is we're going to create our initialize function.
Okay.
So that's our define dunder init.
Self, none. Mine looks exactly like yours.
Okay. So just thinking ahead,
Mm-hmm.
you can restart a game. So we probably want to clear the board. So I'm going to define a function
Okay.
called clear, which takes self, put pass there.
So we'll call it CLEAR, Dunder. Oh, no.
No,
I'm
no,
not
no
using it.
dunder. Just
No Dunders. Clear and self. Okay.
another function is that we're going to check winner. That also takes self, or may not take more later, but it's kind of building up
Mm-hmm.
a template. Also, I got my cheat sheet over here. And then we need the ability to set something. And I'm going to say that we're going to set the grid. That takes the self.
Mm-hmm.
And like I said, we're going to have 9 positions. I'll call them slots. So we want to know what slot to fill in. That's pretty much the makeup of our
Self, comma,
board.
slot. All right. And then colon. And then another pass. All right. I am caught up. Oops. Whoa.
Mm.
Pass. I typed pass, and then before I hit enter, it substituted some other jumble of code that began with a P that we haven't gotten to in class yet.
Oh, you can just get rid of that.
Yeah,
Uh,
I did.
all right, so the initialize is probably, we're going to clear that. What we need to call self, not clear, so we want to clear ourselves.
So we're going to say self.clear.
And then in clear, we want to set up our grid. So we say self grid
All right.
equals, and we're just going to say an empty list.
Oh, interesting. Okay.
And
Oops.
we need to fill that in with something.
Yeah. Oops.
Now we could hand code that, or we can put it in with code.
Code with an array and put zeros in every place,
We could,
or
but I'm going to sidetrack and teach something else.
all right.
We could fill it all with zeros. Zeros make perfect sense.
Mm-hmm.
But sometimes you want to use kind of names to represent numbers in case the numbers change. It's not really going to change that much in tic-tac-toe, but
Mm-hmm.
as we move forward, we might want to have things that are more constants that we can actually change if we need to.
Mm-hmm.
So I'm going to introduce a concept called an enum, which is a way of just defining constants. To do that, we have to do something we haven't done before, which is we need to import something. An import is saying there's something out there that's defined and I want to use it.
Uh-huh.
So from the module enum, we are going to import int enum.
Okay.
And enums are a special type of class. So to define a new enum, which I called it endgame, we are going to create a new class, and it has this syntax we haven't talked about before.
Okay.
Put pass in here so then we can talk about it. So when you create classes, they can actually inherit the data. You can make, we talked about cookie cutters.
Yeah.
A class can be a cookie cutter,
Mm-hmm.
but you can have inheritance or derivation of something that was previously defined.
Mm-hmm.
And the syntax for that is these parentheses that says what your, so there's a cookie cutter that we imported called int enum,
Mm-hmm.
and we want to make something that has that but changes it in some form.
Okay. I'm familiar with the class. I'm not familiar with the importing.
Import, other languages say include or
Mm-hmm.
other things, but somewhere there's a file out there
Mm-hmm.
that defines this. Int
So
enum.
in what I'm picturing for Artemis is we might be writing a mission script and we might include a Python file
Mm-hmm.
that is our rules for this version of Artemis. So
Yeah.
I want to play in Artemis, Artemis for a second language. Artemis English is a second language. So I would say include the rules for Artemis English as a second language in this script I'm about to write. Something like that.
Yeah, maybe I'll
Like
even jump.
one Python file would include another,
Yeah, so I'll jump sort of way ahead and
or
show you
would
some.
import another. I mean, import.
Yeah, so here's one of my Artemis scripts, and
Mm-hmm.
I'm importing from the scatter module something to do
Mm-hmm.
scatter. I'm importing a player ship, which is a base class for creating player ships, space
Okay.
objects, tick dispatchers, and damage
Mm-hmm.
dispatch. All these things that these are all built into a common library that I'm creating, so I can create mission scripts and get a lot.
Library. Okay.
Yeah,
Got it.
a library is made up of a bunch of modules, and in this library SBUtils, it has a bunch of modules: player ship, space object, tick dispatcher, damage dispatcher, console dispatcher, and I'm importing objects from there to reuse.
Okay.
And then these down here are in my project. I have something called a harvester, and I import the harvester, and I build a space dock, import the space stock. And then I have a specific type of player that derived from playership. That's my player for this particular mission.
Okay.
So this is all the stuff that I can import. So that's kind of where this can head.
Okay.
It's a way of libraries and modules and files are ways of compartmentalizing code and being able to reuse it. Reuse is something that Artemis XML never had unless
Right.
you went off and used my Artemis macro language,
Hmm.
which that the intent of that was to make it modular like this, as well as enable reuse. So this is just a way
Hmm.
of doing that. So let's put that away for a later date when we can look at that.
Okay.
And we're
So
doing
I've got to say I'm curious about what I can import here. What is int enum? I assume we'll get to that soon.
int enum is just a way of making a word represent a number. So I'm going to say these are the state of the things in the grid. Or I've actually started end game. So the end game conditions are X wins.
Okay.
And let's just say that equals 1. The number's not important. The concept that X wins and O wins is more important than the number. So we want to put a name to a number. And then there's a draw, and it's going to equal 99, just to show that these don't have to be sequential.
Okay.
And then we're going to create another enum to represent whose turn it is and what to put in the slots. And we're going to call that turn, for lack of a better name. Int enum. It's also an int enum. And the first one is, we're going to say it's unknown. We don't know, or we could call it empty, but I'm going to call it unknown. But it's going to represent an empty slot. And X turn, I'm going to say that equals 1. And O turn, I'm going to say that equals -1.
Oh, interesting. Okay.
So
Oh, geez.
the way that I do tic-tac-toe, some of them do it where it's 0, 1, and 2. I like doing 1 and -1 because then when you do your checks, if it equals 3 or -3, you know you have a winner. But we'll get to that in the end. So we'll revisit clear, and what we want to do with the grid is we want to fill the entire grid with our representation of unknown state,
Yes.
which is turn.unknown. So we could, put in here turn.unknown, comma, and put it 9 times.
Self grid equals, all right.
We
Then
can't,
it's turn.unknown. All right.
we could do this and do it 9 times. Or we can use that for loop that we learned before and say for, and it really doesn't matter what the value is. This is an interesting a chance
Really?
to describe that. So we want something from 0 to 8, which is in the range of 9. Using the underscore in Python and some other languages basically says this, I really don't need a variable. The variable is not important.
Oh, really? Huh. All right.
And what we're going to do is in self.grid, we're going to do something called append. We're going to add a value, and that is going to be our turn.unknown. So we're going to loop through 9 times and append to our grid list unknown. So we have now 9 slots, and they're all empty.
Hmm. Semicolon. Okay, what did I do wrong? Semicolon there, self.grid.
Not semicolon.
Oh,
Colon.
no, it's a colon. It's self.grid.append.
Yeah.
Got it.
I can make this bigger if you need it.
No, 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 no.
Okay.
It's big enough.
Good, because that was kind of.
Mhm. All right, so self.grid.append turn.unknown. So turn is a class and turn.unknown is 0.
Yeah.
Turn.xturn is 1 and turn.oturn is -1.
Yep.
Okay. Wait, I've got a turn int enum. I got a typo. Okay, typo fixed. I had in enum instead of int enum,
I see.
and it was flagging it as something was wrong. So
Another thing we need to initialize, and we're going to do this in the init instead of the clear, is we're going to say whose turn it is.
self.
So we're going to say self turn equals x turn. Well, I'm sorry, turn.x turn. So when we create a board, we clear it, and then we set it so that it's x's turn.
X always plays first. Gotcha.
But as you'll see later, the loser goes first eventually. But just the
Okay.
very first time we say, okay, somebody got to be first, and it's x.
Okay.
So now we need a way to put stuff into the grid.
Right. We've now got a, well, it's not much of a grid. It's got not 3 by 3. It's just not a grid of not. It's a line of 9 spaces.
Yeah.
Mm-hmm. 9 zeros.
So I wonder if I should take a divergence and show how to display this so that we can kind of show that as we go
Okay.
with a print. And what I'm going to do is I'm going to try to keep the board pure, that it just, all it does is know how to play tic-tac-toe.
Uh-huh.
And then I'm going to do something. Let's create another file. And we're going to call this string_render. And I'll explain why.
Let's go over there.
This is kind of like, I think,
Ah,
good separation. Like in gaming, you have your state of your game, and then you
mhm.
have the ability to display it, and then you have the a way of interacting with that data.
Okay.
And actually, in the computer world, this is called model view controller.
All right. So I am also in string render.py right with you.
Okay. Let's peek at my cheat sheet on that one. And the model stays pure. The model in our case is the board.
Mm-hmm.
The view, which is our renderer, can know about the model. Its job is to display things about the model.
Okay.
And then our controller, which we're also going to build into this thing called a renderer, is responsible for getting user input and making changes to the model. So the view just views the data. The model is changed, but it's a pure model, doesn't know anything about the external world. And this thing called a controller or an updater, it takes input or external forces and makes changes to the model. That's kind of the way to separate it. So in that vein, we know about the board, so we should probably import it. So from the board, from board, we're going to import board. We're probably going to want to know the endgame situation. So we import our endgame enum and our turn enum. We want to know all about those.
Okay.
And we're going to create a class called string renderer. String renderer. Renderer. And its job is to render things.
Mm-hmm.
And I'm going to make it so that it doesn't hold on to the data. It is given the data whenever this is kind of like Tom always talks about immediate mode. This is kind of the immediate mode.
Okay.
You are given the data and you just render it. That's all you do. You don't hold on to it or anything like that. Somebody else's job is to hold on to that. So we'll define a function called render. And it takes a board.
And then, okay.
So what we're going to do with this board is we're going to build up, we could say print, 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 but well, there might be a way of print in Python always ends with a new line. So you can't, just print part of a line.
Mm-hmm.
So we're going to build a string. I'm going to call it S, and
Oh,
it's going to be blank to start with.
okay.
And actually, we're not even going to print this thing. We're going to return it at the end. Oops, it should be lowercase s. So we're going to create a string and eventually return it from this render function.
All right. Gotcha. No, I don't want it to be suppress or spec or anything like that.
So in general, we're going to go for our slot in our
Slot.
board.grid that we got passed in. We want to do something with that. And what we want to do is, if it's An X, we want to represent it as X. If it's an O, we want to represent it with the letter O.
Mm-hmm. Otherwise, it's an empty space.
It's an empty space. Or in this case, since we're going to be printing it on the screen, it could be a period, or we want to like say which slot those are. So we're going to actually put the number in.
All right.
Okay. So let's just handle the case of X and Y first. So if our slot equal, which is it's equal to X underscore turn, then S plus equals X. That plus equals means it kind of appends. It's a concatenation with thing.
Oh, okay.
Take its current value and add this to it. In the case of a string, it appends to the string.
Mm-hmm.
And then we use that funky Elif the slot equals turn dot o turn s plus equals
If slot equal turned. Oh, I got it. Yeah.
else we want to do something. I'm going to say s plus equals we wanted the index. Remember we were talking about you don't need indexes.
Yeah.
This is my opportunity to explain when you do need the index, there is something that you can do.
Okay.
There's a special function you can wrap a list or any other thing in there called enumerate. If you wrap enumerate around there, it actually returns two things. The first thing being the index, and the second thing being the actual object. So this is kind of a new syntax here where it's saying, this thing spits out two values, and I want you to put those two values in these things. So index, comma, slot in enumerate board dot
Index,
grid.
comma, slot in enumerate board dot grid. Okay. And so now S plus equals the index of that, which.
We need to convert it to a string though, which is
Okay.
index. And that index is 0 based. You want to leave it 0 based, or we can add 1 to
So
it?
we're going to index plus 1.
Yeah, okay, that's right.
Okay.
And now since we have that index, every third one we need to know, we need to kind of put a new line.
Hang on.
Okay, that's fine.
Okay. I did not define my index. Okay. INDEX. Oh, for index, comma, slot. Ah, okay, got it.
Okay. So if the index mod 3, you may know those words since you're a math whiz.
Yeah,
But
modulo. All right.
the modulo, that's how you say if the modulo is 2, which means
If
we got 0, 1, 2. That means we need to
X.
add a new line to the string,
Ah,
which is done by adding this funky \n, which means new line. It's a pretty common in multiple languages that \n is new line. And that is how we render a board.
Okay. We build a string to render the board. We haven't actually printed the string.
That's correct. So we also need something to run everything. So we're gonna make a new one. We'll call it play.py.
Okay. All right, I'm with you.
Okay. And we need both our things. So we need from our board, we need to import board because we're going to create one of those. And
Are you making a play.py now?
yeah, play.py.
I don't see anything happening on your screen anymore.
Oh my goodness, because I started in my cheat sheet, I wrote it over there.
Okay.
I got
There we go.
2 copies of Visual Studio running.
Okay.
And so yeah, import website from board, import capital board, and from, dang it, and from our string renderer.
Wait. Import board, not broad.
Yeah, I was testing you. Yeah,
Yeah.
that's the ticket. And from our string render, we bring in our string renderer.
From board, import board. Oh, okay. Huh. From string render. All right. I'm just going to go take a little peek at what was in string render. Okay. Now I see it. So I'm going back to play.
And first we're gonna create our board and b equals board. And then we say r equals, oh no, we're not even gonna do that. Don't even do that. Let's just, we won't finish this code yet. We're just gonna print the board once. So we need to say s equals string renderer.
So we're not doing the R at this time.
No.
So S.
And I will actually explain a subtle thing that we did with this string renderer.
String renderer. B.
If we ran this, it should print 1 through 9 on 3 lines.
If we run play.py. All
Nope,
right.
it didn't. Oh,
Oh.
I know why, because we didn't print this.
Oh.
Print s. There we go.
I got it. All right. Render. Oh. Okay, good. Syntax there. Okay, and oh, invalid syntax. All right, I have a typo somewhere. Not very quickly seeing where.
Do you want to share? And I can
Yeah,
help.
okay. Um, I will share. Let me see if I can. Oh, wait. Am I looking at the email? Sure.
Oh, I see it. Okay, let's see.
Okay.
Valid syntax line.
Oh, line 1. There we go. File. STDIN. I don't know what that means. I didn't spell board wrong, did I? It looks like I spelled it right.
No, everything looks right. How did you do that? Did you tap the little play button? Can you do it again?
I just did it again. Invalid syntax.
Hmm. Tell you, can you like, can you hit the little trash can down there? I don't.
This trash can down here.
Yeah.
All right, kill terminal.
All right, and now run it again. I just.
Now run it again.
All right. Let's see.
From board, import board. Cannot import name board from board. All right, maybe I spelled the name wrong. Oh,
Oh, it's
this was
not.
supposed to be
Ah,
capital
that's supposed
board,
to be
wasn't it?
capital. Yeah, yeah. Okay. There we go. Yeah, that's just a standard convention that class names are capital. Well, they
All right. Still
start with.
problem.
Hmm? Well, now you got to go into you and play, and then do you hit the little play button?
Yeah, I hit the play button and import error cannot import name board from board. All right, let's go back. Board, class board. I capitalized it, BOARD.
Ah, I see. You didn't save it. See the little dot there
There's a dot where?
up in the tab?
Oh, that?
That's
Oh, no, I don't want to close it.
that's showing that it hasn't been saved.
Save.
So you can open again.
Oh, I got to open it again. Which I
Wait,
do by file open.
no, you can just double click on, or just single click on board.py, double click on it to keep it
All
open.
right.
Now,
Now string render is not saved.
that looks to be accurate. You can just hit Control S there. You don't have to close it.
Oh,
And actually, I run where it's always saving. And if you like to do that under the File menu,
file,
yeah, see where it says autosave?
autosave.
You click that, it'll always save.
Okay,
If that's a preferred way of working, I tend to work that way now that I.
gotcha. All right, that's why mine was behaving differently.
Yeah. All
So
right.
if I go to play.py now,
Yep. There it
two,
is.
three, four, five, six, seven, eight, nine. All right.
So we have a good separation. We have an entry point that
Mhm,
creates a board and a renderer, and it renders.
mhm.
All right. So let's build on that.
Okay.
Um, let's see. Well, we need to be able to put something in there. So um, there's something called an input statement. So we're going to get input from the keyboard. This is in play.py.
Got it. Play.py.
And we're going to say our slot is equal to input. And input takes a prompt where you can say pick a slot.
All right.
Colon space to make it look pretty.
And that's it. So the input will provide me a prompt and accept a value,
Yep.
just like my old basic back on the Radio Shack TRS-80 Model 1.
Yeah. But it's giving us a string and we need it to be an integer.
Ah,
So a way to do that is to you can say that I is equal to int slot.
and int is a function.
Int is a function that says take this string and turn it into an integer.
So built-in, yeah, that's actually the same function that was on the TRS-80 Model 1 also. That very line would have worked in BASIC.
Now, the one problem is, though, that this could fail. So we need to wrap it into something that says, I want you to try this. And then excuse me, talking too much. And if there's an exception, which is the except condition, I want you to print.
So I'm telling it to expect or accept.
Oh, it is except. I said the word correctly, and then I wrote. That's why
Okay, accept.
it says bad input. Bad input. We're printing that out.
All right.
Okay.
Okay.
Also, back here,
Mm-hmm.
we need to subtract 1 from our integer if it worked, because it printed out 1 through 9, but we need 0 through 8.
Got it.
Got it?
Mm-hmm.
And then we could say b.setGrid, which we haven't written yet. So on our board, we want to set the grid location.
Okay.
And then I'm going to put comments here to.
So I set the location before I check to see if it's bad input.
Well, yeah, this block. This says try these functions.
Oh, I see.
And
Okay.
if it fails, do this.
Okay.
It's a little weird.
Got it.
But if anything fails in here, I want you to do this.
Okay.
Okay?
Mm-hmm.
And then we could probably render again. But we need to do this multiple times, right?
Mm-hmm.
So what I'm going to do.
Until the game's over.
Until the game's over. Well, I'm going to go back up here and I'm just going to say while true for now, which is basically saying do this forever, which is how almost all games work. This is our game loop.
Mm-hmm. This line. Okay, I have, I think, exactly what you have.
Okay, so we should be able to fill these slots up, but we haven't written that code yet. And we need to check for a winner, which we haven't written that code yet.
Mhm. But we
So,
can, so we, after it takes the input, it then has to set it to O's move.
right. Which we can do in the set grid, which is what I think we should code next. And I think we'll do that because no matter what, in a pure game, if you set the board with valid input, it should switch to the next turn. So that should be in our board, right? So let's go code set grid on our board.
Right. So I'm going to board.py
Yep.
and I have this set grid is nothing but a pass at this point,
Right.
but we need to put some code in that baby.
All right.
Okay.
So first thing, we should not trust whoever calls us. So we will check to see if slot is less than 0 or slot is greater than 8. And we will return, let's return a string that kind of tells the error. So we'll say bad slot.
Okay.
And then Elif. So now we got a good slot, but we need to make sure that that grid is available, right?
Mm-hmm.
So if
Slot.
self grid
Oh,
subslot, that makes sense,
yes.
is not equal to our turn dot unknown, which means empty.
Mm.
And we have an error as well, which is slot already taken. We don't need that to be capitalized.
Okay. Makes sense.
Otherwise, we got good input, right?
Mm-hmm.
So we should set self.grid subslot. And what are we going to set it equal to? We kept track of whose turn it was, which is self.turn.
Ah.
But then we need to kind of swap.
Mm-hmm.
So if self.turn is a verbose way of doing it, but we'll do it. If it's equal to turn dot xturn, then self.turn equals turn.oturn. Else,
Self dot turn. Hang on. Your
that's all right.
self dot turn. Okay. Equals turn dot o turn. Okay.
Otherwise, just set it to x turn.
Okay, I'm with you.
And then since we were returning error strings before, we'll make it so that we return none, meaning we didn't have any errors.
All right, so the none is not in quotes. The
Correct.
none is a value that Python knows what to do with.
Yeah, it's an empty value. It is
Okay.
null, if you've ever heard that
Yep.
term.
Yep. Null is what I'm used to from Fortran.
Yeah, so this is a null value. So now we should be able to actually fill the slots. So let's go over to play.
Well, the opponent won't play yet.
Well, this is just pass and play.
Yes, I get you.
It's not till we get into Artemis.
Oh, hang on. I've got in play.py, I've got something, I've got an indent wrong somewhere. Okay, yeah, there it is. Uh, Let me see. I got everything right. B except no, you're not right. Oh, all right. I think I've got it right.
Okay, so we made set grid, it returns a string or none, so we should probably capture that value and check it. So I call it E or error equals that. And if error is not none, we have an error, so we should probably print it. Oh, error, not E.
Okay, got it.
Else, we need to, we say win equals b dot check winner. Well, we got to write that code.
Okay.
And then I'll look back at we have X wins, O wins, and draws. We probably need an unknown in there too. Forgot to do that.
Mm. So that's back in board.py.
Yeah, I had to check that. So based on these conditions, we need to do something. So back in play, we'll probably do
Back in play.
I'm going to use a new syntax that I didn't teach you. It's called match. It's like a way to say multiple if statements for the same value. So we're going to match the value of win for the case where it matches
Shoot.
end game dot x wins. Oh, and then we didn't bring in, we need to.
Oh, wow, what happened?
Oh, we're getting some ugliness here.
Yeah, I'm getting ugliness here. So what happened? Match,
So,
win, case, end game, X wins. Colon. Okay. I'm caught up with you, and I've got even more ugliness than you do. Case end game X wins. But boy, it looks like I typed exactly what you typed.
yeah, match win and then a colon after that, and then case end game dot x wins and a colon after that. And for now, a pass.
All right. Y X wins. Let me try this again. Did I type a semicolon instead of a colon here? No.
Well, there is an error. We need to import end game, which we need to fix. But
Mine is saying expected colon. Yours is saying end game is not defined. And I don't know why it's expecting a colon.
after x wins,
Yeah,
you
I've
have a
got a colon there.
Hmm.
Mine looks like yours. I just have a different error message than you do, and I don't know. Oh, wait, I got it. It's end game dot X wins because it's yes. All right.
All right, so we can go up and fix that, but I'm going to show you a shortcut. Hopefully this works. I'm on the word end game that has, for me, an orange curly squiggle. I'm going to
Yeah.
hit Control dot.
Control dot.
And
Add from board import endgame.
and that fixes it.
So click on that.
Yeah. And what that did, it put it up here, it fixed it.
Oh yeah, I see that up at the
Added.
top. Excuse me.
That's just a little helpfulness of a Visual Studio Code.
Yeah, thank you, Visual Studio Code.
So we can actually say print X wins, exclamation point, exclamation point. And we're going to do the same thing for O and draw.
Okay. Ah. Control C. It just happened. Oh. All right, case X wins becomes O wins. O wins. And case draw. Okay, got it. I'm with you. Wait. Right. Your print statement for draw looks different from the others with that colon and that.
Yeah, I put a frowny face.
Oh, I see. Oh, I thought that
The parentheses got
the
closed.
parentheses had some significance. Okay.
It's inside the string.
No, I'm just having mine say it's a draw. I don't want to confuse myself with the frowny face.
That's fine. I'll do the same.
Okay.
But the one case we didn't handle is when it's unknown, which means the game hasn't ended.
Okay.
And we're going to use a special word that we didn't talk about. It's called continue. Continue looks at the loop that it's in, and it continues it. And we're in a while loop, so it's going to jump all the way back to the while loop and start over again.
Okay. That continue seems familiar to me from some language I learned.
Yeah, it's a common word. I'm actually going to move that up because what I'm going to add next is really for the common case of all these.
All right. So I will do the same thing you're doing. Move it up to match that one. All right.
So logically, we come out of the match, but we know that the game ended.
Mm-hmm.
So I'm going to put in a little input here. Say Q equals input type. Oops. Type single quote QUIT to end
Q equals.
anything else to play again. So the game's over and we're asking them, do they want to continue basically?
Wow, this is a lot like my Radio Shack Model 1 Basic.
Okay, so if
So
Q,
now I'm getting prompted and I will either get QUIT or I'm going to keep playing. So
if it equals quit, there's
if
just like there's a continue, there's a break, and break means
Q break.
and that breaks that while loop and gets out of it.
Mm-hmm.
Otherwise, we need to actually clear our board.
And I don't need an else after that?
Nope.
Because if it didn't break it,
Yeah.
okay.
Yep.
CLEAR, boom, boom. Wait,
I guess we could add comments like clear the board and play again. Obviously, I'm not a big commenter, but so we have our game loop fully coded. We just need to figure out the end of the game.
Okay. I'm having trouble relating to what your B dot is referring to. Oh, B equals the board.
Yeah.
Okay.
Do you want to call it a board to make it clear? I probably
Well,
should.
we're already using the word board.
Well, I'll show you a trick here. If you highlight
Okay.
it, hit the word, the letter F2, I mean the F2 key.
Okay. Uh, B. I'll highlight the B,
Yeah,
hit
highlight the B.
F2.
Yeah.
All right.
And you can rename that to board, and it should ripple all the way through the code.
Wow. And then just press enter.
Yep. And if you don't trust it, you can go back and look. Now it
No,
should
I
be.
do trust it. Okay.
Yep. Everything is now renamed to board, which is, yeah, that's clear.
Okay.
So that should work. You could just, at this point, we could probably fill the board. Um,
Well, it would when it passes the turn to O, O doesn't make a move yet.
well, I think it should.
All right, well,
I think it should.
let me see if I can get
Oops.
it to run. Pick a slot. Okay.
Oh, something's wrong. Quit to end. Anything else? Why did it do that?
Oh yeah, I got
Oh,
the same thing.
because we didn't code it. Let's quickly code. Let's type in quit just to get out. And then let's go back to our board and have it always return unknown.
We're going to board.py.
Yeah.
All right.
And have it return endgame dot unknown.
Check winner. Where's check winner? Where's check? Oh, there it is. Yeah, that's right. Check winner isn't doing anything yet. Yeah,
It's
so
not doing anything. So if we tell it everything's fine, it should now let us.
return end game
Oops, sorry. Yeah. Endgame dot unknown.
dot. All right. Good. And
Now I think we should be able to. Yeah, we can fill up the board, but it's not going to validate the actual state of the game.
so
Yeah.
we're let's try.
We should be able to fill the board and start getting slot already taken. That's what we'll end up with.
Should I be in play.py and hit?
Yeah, yeah, you got to be in play. Yeah, that play button up in the upper right
Yeah.
corner
Mm-hmm.
plays the active file. I guess I didn't
Right.
explain that earlier.
So, and then I pick a slot and, oh, what just happened?
Oh, you got to click down in the terminal.
Yeah,
You
I'm
might
not
have
down in the
to
terminal.
you might
Right.
have to undo something up in the editor. You
I
probably have.
think I did just have to undo something.
Yeah, I did that as well.
Okay. Yeah. All right.
And I think you can hit Control C once you get to the point where the board's.
Oh, interesting. Wait, can I see what you got? Oh, yeah, yeah, yeah. All right, it's doing the same thing for me. So I'm entering for X, then I'm entering for O, then I'm entering for X, then I'm entering for O.
Yeah. Uh-huh.
All right. I wasn't expecting that. Okay.
What did you expect, just out of curiosity?
I thought I would only be entering for X.
No, we wrote that set grid and had that if and else.
Hmm.
So it toggles between X and O automatically in the set grid.
All right. So, and then how do I exit out?
You can hit Control C
Okay.
down in the terminal.
Okay.
And now we just have to do the end game, and hopefully that would probably be a good breaking point. It's a little tricky, but
The end game. Okay.
Yeah. I mean, check winner was what I meant. My cheat sheet. The way I did it was I actually
Board.py check winner. Okay.
and board. So you can write all sorts of fancy for loops and then check the
Mm-hmm.
diagonals and have all this complicated if statements. I wanted just something that would roll through and it was easy to understand.
Yes.
So I sort of did a data-driven thing where I said, okay, there are a bunch of checks I want you to do.
All right. So
So I have this list of
checks, plural. All
checks.
right. CHECKS. Ah,
And then I'm going to pull a comma in here, and it's like, these are the rows. I want you to check rows. And that would be, I want you to check slot 0, 1, and 2. So that's a list inside of a list.
oh, wait. Checks equal, and then, okay. Then I hit enter, and you're commenting rows, and
So each one of these checks is going to be 3 slot numbers, basically.
gotcha. Mm-hmm.
And for the rows, it's 0, 1, 2, and 3, comma 4, comma 5. But
Mm-hmm.
and then the 6, 7, 8. Those are the row checks.
Mm-hmm.
And then I added for the
6,
column,
comma 7, comma 8, comma, and then
and I have the column checks, which are 0, comma 3, comma 6. 1, comma 4, comma 7.
1,
2, comma
comma,
5, comma 8.
oops. Wait. It's not 1 comma. Yes. All right. It's 0 comma 3 comma 6. And then 1 comma 4 comma 7. And 2 comma 5 comma 8. And then there are the diags.
Exactly. 2 diags of 0, comma 4, comma 8. And 6, comma 4, comma 2, or 2, comma 4, comma 6, whichever you want to do.
Okay. And that does look like all the possible ways to win.
And actually, this is kind of handy because if you want to do, there's the next step I was going to do is, and we can do this in the next session, is to not even go into Artemis yet, but to go into using a graphics library. And when you win the game, having these slots comes in handy because you can highlight the winning pattern.
Mm-hmm.
So, but that's just an aside for now. So we have our places to check. And it's kind of complicated, but not so bad. Um,
So it's got to return something, and that something has to be, it has to know whether it's checking X's or O's here.
There's three states we need to figure out.
Yeah.
If X wins, if O wins, or if it's a draw.
Okay.
Okay.
Yep.
So draw means that there is not a zero, or yeah, there's not an unknown at all, which in our case is 0. So I'm going to do some. First thing I'm going to do is I'm just going to use the letter G as a shortcut to equal self.grid, so you don't have to type self.grid all over the place.
G equals self.grid.
And then I'm going to have a variable called draw, and I'm going to set it to G sub 0 dot value, which is, that says I'm looking at, I know there's enumerations in there. I want the value of that enumeration.
Mm-hmm.
And if this equals 0, well, I'll get to that in a second. But what we're going to do with the draw is I'm just going to multiply every slot as we go through it. And if at the end we go through this and there's draw is not equal to 0, that means there wasn't a 0 at all in the grid.
Okay, I see. Yeah. So
rather than having all these ifs around there, I'm just going to use math and just put it
that's a
where it
great
goes.
idea. Wow.
And the other thing I'm going to do is, because I used 1 and -1, I can add all these things up, and if it equals 3 or if it equals -3, I know that I have a win. So,
I see.
because if I've seen a lot of them, they use 1 and 2, but if you could have, can't really use the math check. You'd have to do all these ifs, because you could have 2 1s and a 2, or a 1 0 and a 2, and think that you have all ones or
I
something.
gotcha.
Yeah, but so
I'm going to pause the recording for a second.
okay.
Oh, okay, let's go.
I think we can probably finish.
All right.
It's not really that complicated when you do the way I did it. So we need to enumerate our checks, right?
Mm-hmm.
So I'm going to do that trick where I get the index and I get the thing to check in enumerate checks.
Okay.
Um,
I'm with you.
and mhm. This is a bit of a hack because I know there's 8 checks and there's 9 slots. So you're gonna have to bear with me here on
All right.
my trickery and cuteness and how I did this. But we already got grid 0, so I'm going to use index +1 to roll through this dot value, and this is my draw calculation. But I through this, I'm going to hit every slot in the grid and multiply draw by that, and come to the determination that is a draw as it described before.
Mm-hmm.
This is just a bit of a slickery. And then the next thing I'm going to do is I'm going to do kind of double indirection here using
Mm-hmm.
my check. So I want the grid for the check slot 0. And I want to add that to, oops, I'm missing an equals. That's why it's yelling at me. And I want to add that to G sub check sub 1 and G sub check sub 2. If I spelled the word right, it might not yell at me. So I'm checking the various check patterns. And as we discussed before, if the sum is equal to 3, positive 3, that means return endgame dot x wins. You can do a else if or just an if, since the above was a return. If it equals -3, then O1.
Okay, so then if sum equal -3, gotcha. I had caps lock on.
I'm going to go back and do something that we're probably not going to use until we get back into
-3 return. Okay. All right. Oh, self.winning lock. Okay, let me go up there.
I'm going to put that in both of those. And what that's going to do is it's going to capture the, uh, the locations of where the winning location was. So if it was out in the diagonal 048, we'll capture that 048 where the places where the winning happened. We're not going to use it in the text-based one, but we'll use it in the graphical one. And we're just going to reuse this code later. So I may forget about it later. So I just want to add it here. And the one last thing we need to do is outside of the for, we need to say if draw is not equal to 0, return endgame dot draw. Otherwise, we're going to return our endgame unknown. And that is some of the least complicated.
Yeah, that's
How to
very
determine
elegant ending condition checking. I love it. Okay.
So I believe if we both coded this correctly, we can go over to play.py and actually play games.
We can play. We are still playing as both players, but yes.
Yeah.
All right, let's try it. Pick a slot.
X wins. Yay. Now do the
X wins. All right. Oh, interesting. O did play first for the second game.
Yeah, that's the way this is coded. The loser always goes first in the next game.
Okay. The turn taking just continues.
Yeah.
Gotcha. And O wins. All right. This is functioning.
The tricky one is trying to get a draw by just mashing keys here. You got to pay attention to get a draw. Whose turn is it? Probably should say whose turn it is. But 7, 8. It's a draw. I did it. So we have a functioning game. Checked all the conditions.
Mm. Okay. Very nice.
So the next phase could go one of two ways. I I planned on doing, could even maybe even show you
Okay.
that version if I remember where it is. Ah, it's in the same folder because I reused everything. So you see my screen?
Mm-hmm.
The next phase, I planned rather than going right into Artemis,
Mm-hmm.
was to actually take the same code but make a graphical game. And the idea behind that was to reuse external libraries, because
Okay.
Artemis is sort of an external library. It's this huge library that we live in,
Okay.
and some of the stuff that I'm trying to set up for Artemis is the ability to reuse other code. So
Mm-hmm.
you have to learn the process of doing that, and I thought it would be nice to do it outside of the confines of Artemis, to do that. So it's really just creating a new render and a new loop
Mm-hmm.
because you're reusing the same board logic.
Mm-hmm.
And it's the next phase because you know, you draw and then you have to capture input, the mouse clicks and things like that.
Mm-hmm. I'm with you.
So that would be the next one. And then after that, I've coded the main GUI screen playing Tic-Tac-Toe,
Mm-hmm.
having the main GUI and the client play each other in Tic-Tac-Toe,
Mm.
and then um, a one where the player ship through comms plays Tic-Tac-Toe with multiple stations, all of which shows different aspects of Artemis and introducing the different hooks and handlers that you do.
Okay.
So the first one being the main GUI screen, and then you add the client to show the interaction between the client pre-game or pause game client server interactions.
Okay.
And then that that's sort of the plan.
I like the plan. And do you think that chunks out in time about like what we did tonight?
We might, yeah, yeah. I think the hmm. Yeah, it might like maybe 2 to 3 more of these sessions, maybe to get to that point.
Okay. I
And
wish others would join us.
well, we recorded it, so
Okay.
we'll see what happens there. And some people like Kai and maybe even Darren may feel they already knew these basics and maybe catch up quickly, but or I don't know. The key is to spread the knowledge.
Mm-hmm.
Along the way too, I at some point along the road, and it would probably be when we get to the comms one, introduce you to the ability to, uh, yeah, here. So I have my own libraries
Mm-hmm.
and I have it set up on GitHub and uh, to help you and other coders to just be able to reuse that simply.
Mm-hmm.
And I even have this nobody ever I sent an email out, but it's real simple to like actually we could probably stop the recording,
Yeah,
but
let's stop the recording now. All right, end of the lesson for today.